Hi, this is Mrs. Damavandy. We're going to go over a couple of examples to help you out with your Build and Solve Equations worksheet. So it'll look something like this. I'm going to show you what I want you to do in each column, and I'm going to explain to you what the visual means and how it can help you solve equations. So equations are like balance beams. You have to keep both sides equal to be able to have a true equation. A balance beam, for both sides to be equal, there has to be the same amount of weight on both sides. So like if you take off 1 pound on one side of the balance beam, the heavier side will go down. But if you took off 1 pound from both sides, that was already equal, it will still remain equal. Kind of that idea. So first I want to go over what these shapes mean on this balance beam. So the problem column, this line with the segment that's splitting it halfway is representative of a balance beam. So what's on the left side is equal in weight to what's on the right side so that they're balanced. So you have some weights that you know how much it is. Like right here, we know that this is worth 5, okay? But we don't know how much the triangles are worth. But see how these black triangles are identical? They're meant to represent the same thing. So we have 3 of the same unknown things on the left, and that's supposed to equal 5 plus 2 of the unknown things on the right. So how this helps us out with equations is that a black triangle like that, a filled in dark triangle, is supposed to represent a single positive x, because x is what we use to represent some unknown. So over here, we have 3 unknowns, or 3 x's, and then on this side, we have a positive 5, and we have 2 unknown x's. So that's how we can convert these visuals into math expressions. And to make an equation, we set the 2 expressions equal to each other, because these 2 expressions are supposed to equal the same amount of weight because we have a balanced balance beam. So this is how we can take the picture and make it into an equation. The equation for problem 5 on my page is 3x equals 5 plus 2x's. So that's what you're going to write in the second column where it asks you about the equation. Okay. We also need to figure out what the x equals. Okay. In the third column where it says your solving actions, this is where we're going to show our steps to solve. So we have the equation 3x equals 5 plus 2x. We want to take away normally constants from both sides to get like the regular numbers on one side. But see how there's just a 5 by itself here? We don't need to move that, because if we keep moving it, it'll just move from the left side to the right side of the equation, from the left side to the right side. So it's better to start with trying to move the x's to the same side. So since my constant 5 is already on the right side of the equal sign, I'm going to work with getting rid of plus 2x from the right side of the equation. I need to do the inverse operation to undo and get rid of it. So the inverse of plus 2x is to subtract 2x. I would subtract 2x from both sides because we're taking off the same amount of weight from both sides of this balance beam to keep the equation equal. And then when we simplify that, 3x minus 2x's leaves us with just an x. And then when we have 5 plus 2x minus 2x, that cancels out and we're left with just 5. So 5 should be our solution of what these unknown triangles represent. They represent a 5. So to check it, if we have, we could plug it into our equation, like we could do 3 times 5. Does that really equal the 5 plus 2 times 5? So 3 times 5 would be 15 on the left, and then we have 5 plus 2 times 5, which is 5 plus 10, which becomes 15. So yes, they equal because both sides are equal. You can show that it checks like that by plugging it into your equation, or you can come over to your visual in the problem column, and then if this is a 5, and a 5, and then these two triangles are also 5s, you can count up the weights. So this is going to be 15 on this side of the balance beam, and then 5, 5, and 5 add up to be 15 as well. So it does equal, and we have a balanced balance beam. Okay, so that's what you're going to do in each column if you already have the picture like in the problem column drawn out for you. But sometimes you're going to start with an equation and have to go back and draw the picture. So let's do one like that. So if we look at the left side, let's do our left side in this blue. We have two x's, which are two unknowns. And remember, our unknowns, we're going to do our filled in triangles if they're positive unknowns. So since this is positive 2x's, we put 2 of our unknowns. But then we have a plus 3, so that means we have a weight that we know that it's 3. And then we have 3 more unknowns. Okay, that's going to be our left side. And let's get a different color. Let's do our right side in this yellowish color. So we have one unknown, and then we have a weight that we know it's 11. This picture represents the equation. Okay. Having the picture can help us simplify the equation, because if we look at how many unknown triangles we have on the left hand side, we have 1, 2, 3, 4, 5. Okay, we have 5 of these unknowns put together plus an extra 3 weights. Okay, this expression that I wrote, 5x plus 3, is what you get when you actually combine like terms and add up the 2x and the 3x, which is one of the solving actions. So when you first start to solve, if you were just solving the equation, you would add the 2x and the 3x and get 5x plus 3 to simplify that side. Okay? And then you can also see visually why we cannot combine the terms of x and 11. So these are not like terms, and you can see in the picture, you can't really combine a triangle that you don't know how much worth it is plus 11 because you can't physically add it together. So this still remains something we don't know plus 11. Okay? So we have 5x plus 3 so far equals x plus 11. So we still need to continue solving and figuring out what x is, but I'm going to show you how you can do some of the solving actions with the picture over here. So these are weights, remember? And we know that each of these triangles all represent the same amount. So if I take the same amount of triangles from both sides, it's going to keep the balance being balanced. So if I take off one of these triangles from both sides, we still have a balanced problem here. It's just that instead of the 5x's and 3 equaling 1x and 11, we now have just 4x's over here and the weight of 3. And then the opposite side, we only have the 11. Okay? This is one of our solving actions. What it would look like if we were just solving the equation without the picture is that what we've done is we've subtracted an x from both sides. And we would do this to get this x plus 11 to just be the 11 on the right side. You can work with your x terms first, or you can work with your constants first. It doesn't matter. So if we take off x from both sides, we're left with 5x minus 1x is 4x's, and then also the plus 3 you guys has to remain and come down. And then the x minus x will cancel out, and you're just left with that 11. So you can see how the algebra of writing down the steps is the same as what we're doing with this visual manipulative. You can also take out amounts that you do know from both sides. So if we go back to this picture, we have a weight that's worth 3. If we take that away, we just have to take away 3 of this 11 as well. So if we imagine, let's put our 3 back. If we imagine that our 11 was actually made up of a weight of 8 and a weight of 3, so 8, 9, 10, 11, if we just take off the weight of 3 from both sides, we can see what remains. It's that 4 of these unknown values has to equal this leftover 8 right here. We would get the same thing if we just show subtracting that amount of 3 off of both sides of the equation, like I'm showing over here under the solving actions. So subtracting off 3 from both sides, 4x plus 3 minus 3 would just be 4x's, and then 11 take off 3 leaves us with 8. Okay? So when we get down to an equation that looks like this, 4x plus 4 times x equals 8, this is where our last step is to divide by that coefficient 4. So 4 is multiplying x, so the inverse operation to undo it would be divide. So I'm doing the bar to show divide. Divide by 4, divide by 4. We're left over with just x, and then we just have to simplify. 8 divided by 4 equals 2. So each of these unknowns have to be a 2 to total up to be the same amount as the 8 so that it's balanced. So we can put our solution here, that it's a 2. Under the check, you could go back to the original equation and plug it in. So if you go back to this equation we started with and plug in a 2 for every x and then simplify both sides, we're hopefully going to get the same amount. If you aren't erasing part of your picture, as I was, to kind of show you the steps, we started with, here's 2 x's and then the 3, and then 3 more x's, and then here's the x and the 11. If we just go in and put our solution, so this is a 2, 2, that's 3, 2, 2, 2. We have 2 and 2 is 4, 3 more is going to be 7, and then 2, 2, 2 is 6 more, would be a total of 13 on this side. And then on the right side, if that's 2 and 11, that should also be 13. So we can see that it's still balanced, still equal. Okay? So there's different ways to check. You can use your picture to check. You could plug in the x and use your equation to check. Okay. So one more thing I want to go over to help you. We're going to see it in this equation with number 3. So in this equation, we have positive x's, but we also have negative x's because the sign in front of the number or the variable affects whether it's positive or negative. So that one that I highlighted is a negative x. To show the difference between negative and positive x's, so a positive unknown is going to be filled in like this. That represents a positive. If you have a negative unknown or a negative amount of x's, we're going to leave it unfilled. So like it's white. So like the black filled in ones are positive, and then the open unfilled ones are going to represent negative. Okay? So when we're drawing the picture for this one, I have a positive x right there, and then I have 3 more x's. 1, 2, 3. So there's another 3 positive x's. But then I have a single negative x. So all I have on this side is 4 filled in positive x's and 1 unfilled negative x. And on the other side, we just have a weight where we know the amount is that it equals 30. So one thing when you have positive and negative x's, if you have a filled in triangle or X and an unfilled triangle or X on the same side, they cancel each other out and become 0. So we could imagine putting these two together and they're going to cancel out and become 0 because it's positive and negative of the same amount. So, like, if I said that a filled in triangle equals a 5, that means the unfilled triangle equals -5. And if you were to add 5 and a -5 together, since they're opposites, they equal 0. So really, doing that, we're left over with this equation that there's really just 3 unknown x's on this side that together equal 30. And you could probably already split that up in your head. What if this were 10, 10, and 10? 10, 10, 10 add up to be 30, and that's what I have on the other side, 30. So that's kind of essentially your solving actions, is you're splitting up the 30 into 3 things. So first, first solving action that we would really show if we were solving it algebraically is that this positive x and this single negative x cancel each other out. So we're just left with 3 x's. That's one way to show it. That equals 30. And then dividing that 30 into 3 things, which would be dividing by that coefficient 3, we'd get x equals 10. That's how we can show the solution we got. I already kind of showed that I checked it by saying, okay, I have 3 things that are 10. I know that adds up to 30. And I know the other side equals 30, so it's got to be equal. Another way to show solving this equation, if you try combining your like terms first, that's totally fine. If you have 1x plus 3x, that's 4x's, but then you have to take away 1x, you would still end up with there are 3 x's total, or 3 unknowns, okay? So that's what happens if you see the white triangles that aren't filled in. They represent a negative unknown, okay? So with all of those, hopefully you guys can work together and write your equations with the pictures and solve them and check them, okay?